Alright, hello everyone. So this question is asking us to estimate the values for the CNC and the CNH bond angles in the secondary amine dipropylamine. Here we have 4 different answer choices labeled A through D, proposing different values for both bond angles. These values include 109 or 109.5 degrees, 120 degrees, or 107.3 degrees. So let's go ahead and get started by drawing out the Lewis structure of dipropylamine. Dipropylamine is a secondary amine, which, if you recall, has an initial Lewis structure in which nitrogen is bound to 2 R groups, as well as 1 hydrogen atom, and it has a lone pair of electrons. This is because nitrogen, in order to fulfill its octet, prefers to have 3 covalent bonds and 1 lone pair of electrons. Now, because we're given a specific structure for this amine, we're going to replace the R groups with the carbon chains provided in the text of the question. It just so happens that the R groups are the same because we have 2 propyl groups or 3 carbon chains on either side of nitrogen here. So when drawing out the Lewis structure of an R group, the atom with the highest bond preference should go in the center. Carbon has a bond preference of 4, whereas hydrogen has a bond preference of only 1. Because of this, carbon should be in the center of the Lewis structure of the R group. So carbon here is in the center, and hydrogen atoms are connecting to each of the carbons. This allows for hydrogen to fulfill its 1 bond requirement and for carbon to fulfill its 4 bond requirement. So once again, because the R groups are the same, I'm going to go ahead and substitute the R on the right side with the same R group. So with this in mind, let's go ahead and talk about bond angles. Recall that bond angles are created between 3 atoms that make 2 bonds. To determine the bond angle, we're going to look at the hybridization of the atom in the center of the bond angle, or simply known as the point of reference. In both cases here, the atom in the center, and therefore the point of reference, is nitrogen. To understand the hybridization on nitrogen, we have to recall the number of quote-unquote groups surrounding our target atom, in this case nitrogen. When I refer to groups in this context, I'm referring to 2 different categories. Either lone pairs of electrons, or other atoms connecting to my atom of interest. So focusing our attention back on nitrogen, nitrogen has 1 lone pair, as well as 3 atoms connecting directly to it. This makes a total of 4 groups, which, if you recall, corresponds to sp3 hybridization. Now, the bond angles are not only determined by hybridization, but also the number of lone pairs surrounding a given atom. When an atom is sp3 hybridized with 0 lone pairs of electrons, then that bond angle is generally 109.5 degrees. But when you increase the number of lone pairs on that sp3 hybridized central atom, the angle tends to go below 109.5 degrees. To be specific, when 1 electron pair is present on an sp3 hybridized atom, then the angle decreases somewhat to about 107.3 degrees instead. So this means that our answer is going to be option D in the multiple choice. Because nitrogen is in the center of both bond angles, and nitrogen is sp3 hybridized with one electron pair, their bond angles are going to be 107.3 degrees. For both the CN-C bond and the CNH bond. And there you have it. So with that being said, thank you so very much for watching, and I hope you found this helpful.